Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Cece.
I'm Jed. For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media, Facebook, Instagram, Twitter, and YouTube.
All right. So, Jed, where do you go to school and what grade are you in?
I go to Rio Elementary, and I am in 5th grade.
I was 5th grade.
It's a lot of fun.
It's a lot of fun. What's so fun about it?
Math.
Oh, it's like, okay.
And reading.
You're saying that because you're on Do the Math?
No.
So you like doing the math. All right. Is there any math that you've done so far this year that you think has been a little more difficult and you probably need a little more practice at it?
Probably adding and subtracting mixed numbers.
Okay. So mixed numbers, adding and subtracting them. All right, so I think you brought some. We'll take a look at a little bit about that later on today. If you could change anything about 5th grade to make it even better than it is right now, what would you want to do?
Probably have a bit more reading time.
A bit more reading time. So how much reading time do you have now? Like a half an hour, an hour?
We have 15 minutes.
15 minutes, okay.
Except I would prefer it to be like half an hour.
Okay, all right. So, but otherwise everything's going pretty well. Yeah?
Mm-hmm.
I know that Del Rio is a pretty special school. And why do you think Del Rio is a special school?
It just has a lot of good teachers.
Well, good. It has a lot of good teachers, and I know the administration is pretty awesome too, because every time we have a Del Rio student on the program, the principal comes to see you guys on the show and make sure that you guys are recognized and you have their support. So that's pretty cool. I think that is awesome. All right, you're going to help me out with a social media problem of the day? All right, let's take a look at it right now. So it says, what is the mean? So what does that even mean, the mean? You know? All right, so the mean, it says 1, 2, 4, 4, 5, 6, 7, 7. And we have a couple of options up there, 4.5, 5, 6, and 4. So looking at the answers that are up there, what do you think they could possibly be looking for with those numbers that are up there? Because we'll go over what the mean means. But right now, do you have any idea what they might be looking for, looking at the string of numbers they gave us?
Maybe like halfway point.
Good, that's a nice thing, right? The halfway, right? So if we looked at that right there, because those numbers are in order, right? And how many numbers are there?
There are 8.
There are 8 numbers, okay? And you said the middle, right? So in statistics and stuff, what they're getting at here, have you ever heard of mean, median, and mode? Probably not if you haven't heard of mean, right? Okay. So the mean is the average of all the numbers, okay?
Right.
Do you know how to find the average of some numbers?
Estimate?
So what we're going to do is we're going to add the numbers up and then divide it by how many numbers there were.
All right.
So think about this. If I had 4 dimes, all right, so 4 tens, and I added them all up, what would it add up to be?
40.
40. And how many of them were there?
There were 4.
So the average would be, if I had the 40 and divided by 4, the average would be
10.
10, okay? So here, if I add up all of those numbers, so let's add them up. How would you add up all of those numbers up on that line? Would you add them straight across? Would you combine numbers, go backwards? What would you do?
I would probably combine numbers and then add them.
All right, so tell me how you would combine them.
Well, there's 2 7s.
Okay.
7 plus 7 is 14. There's 2 4s. 4 plus 4 is 8. 14 plus 8 is 34.
Almost.
32.
14 and 8.
14 and 8. 22.
There you go, 22. So we got all the multiples out of the way. So what would you like to do next?
First, let's add the evens.
Okay.
22 plus 6, 28. 28 plus 2 is 30.
Nice way of going about it so far. So what do we have left?
The 1 and the 5.
Okay.
Add those 6. That would be 46.
36, because you were at 30.
yeah.
And it's easier, because I know we're trying to just do this in our head, right? So we have 36, and there's 8 of them. So if we have 36 and we have to divide it by 8, is that going to come out to be a whole number?
No.
Because what's 36 divided by 9?
36 divided by 9 would be 4.
4, right? But we have 8. So do you think 4 could be the mean, the average?
I think it would be 4.5.
You think it would be 4.5? Why do you think it would be 4.5?
Because that would be the remainder. The 0.5 would
Okay,
be the
because you've got a remainder, right? Because you know there's something odd about this, right? The funny thing is, the median is the number in the middle, okay? Now, there are 2 numbers in the middle, 4 and 5. And what you do if you have 2 numbers in the middle, you add them up and divide it by 2. So what's 4 plus 5?
9.
And what's 9 divided by 2?
4. Oh, wait. 9 divided by 2 is 4.
Well, 8 divided by 2 is 4.
4.5.
4.5. Take a look at the 4 and the 5. What do you think comes right exactly between 4 and 5?
The decimal point.
Which is 4.5.
Yeah.
Right? So does that make sense? 4.5 is right between 4 and 5. So the median is actually 4.5, 4.5. And you're saying the mean is 4.5?
Yeah.
Okay. You confident about that?
Yes.
Well, good. Let's take a look at it and see how you are doing so far. There you go, 4.5. So now you know what the mean means, right? All right. So that was our social media problem of the day. Time now for today's Math in the News. All right, today's Math in the News has to deal with an event that happened last week. And we had some of our producers and other people would do the math go up to Tulare. Do you know where Tulare is?
No.
It's north of here. That's all you need to know about, right? So
right.
Tulare is north of here. Have you ever heard of the World Ag Expo?
No.
Now you have, all right, because it happened last week. And if it's called the World Ag Expo, who do you think goes to it?
People from all over the world.
People from all over the world, and that's exactly who goes to this thing. So this thing is a big event, and as a matter of fact, it is so big, there are 1,200 exhibitors at this thing, right? So that's 1,200 different booths and little setups all around. And this is what's another name for big?
Humongous.
Humongous complex that these things are all at, right? So you can see there's an 80,000 square foot pavilion. Now your bedroom, do you share it or is it just your bedroom?
Just my bedroom.
Just your bedroom. Do you have any idea what size your bedroom is about? Feet?
10 feet by 10 feet.
There you go. I would say that's a pretty good size, right? 10 feet by 10 feet. So if you wanted to know the area of your bedroom, do you know how you would do that?
The area would be 10 times 10.
Right, which is?
It would be 100.
Right, so your bedroom would be 100 square feet. Now these things are 80,000 square feet, right? And 60,000 square feet. So there's a lot of different rooms you could put in that place, right? So they have 1,200 volunteers and 25 staff work the World Ag Expo. And this thing goes on for a couple of days. As a matter of fact, I think it lasts almost close to a week. So it's 3 days that this thing is going on because there's so much stuff to see. You can't see it all in one day. There's a lot of reasons that people go see this. Now, the Central Valley is sometimes referred to as the breadbasket of the world because whether you know it or not, the Central Valley and where we live in Bakersfield produces a lot of food for California, the United States, and the rest of the world, okay? And that's the main reason why they have this Ag Expo in California in the Central Valley. But there are a lot of reasons people go, and product research, because they're always coming out with new items to make agriculture and harvesting it and everything that goes along with it better, right? And networking, people want to see, all right, so you are into developing seeds, and Cece's into making sure that water is being used the wisest way that it can be, and somebody else has some new equipment. So these are some of the reasons why the people go. And we can see some of the numbers right there. And here's also the percents of sectors that people are looking at. And while they were there, they were able to take a couple of shots, some video, so let's take a look at it right now. And there's one of the pavilions. You can see there's just a lot of exhibits. It's like if you were going to a fair or something. This is Gus, and Gus is spraying. And the way that Gus knows where to go is by a software program, and that's what it's following right there. So you can see on the far left, the blue arrow shows where Gus is. Here's some of the equipment that is new, and you drive around Bakersfield sometime, you'll see a lot of that equipment. Obviously, there's going to be a lot of livestock out there, and that was one of the dairy cows, some more equipment, some of the new things that are out there. This, they had like a competition as far as to see how well and how easily people could put things together as far as changing a tire in that case right there. And just indeed, and there's another way that they're spraying, but instead of spraying a lot of things all at once, they're just spraying the specific item as it goes by looking at that light. So the World Ag Expo happened in Tulare right here in Central California, and that was today's Math in the News. 636-4357 is the phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. And right now we are going to go and check in with the Bakersfield Museum of Art downstairs with Sam and see what they're working on today. And I do believe it is the golden ratio.
So today with us from the Bakersfield Museum of Art, we have Maria here. Thank you for being here, Maria. So what project do you have for him planned today?
So we're going to be going over the golden ratio. It's also considered as the Fibonacci sequence. And when we look at the golden ratio, it creates a spiral. And that's because we start with 1, but then as we add the following numbers, so if we have 1, we would add 1 plus 1 equals 2. And then the next square would be 1 plus 2 equals 3, and then we would keep going on, so 2 plus 3 equals 5, and then it keeps growing, and it creates a balanced and harmonious sequence that inspires art. And it's not the only option, but it is one of the options that artists use to create very, pretty and aesthetically pleasing. And we do see the golden ratio in nature, and I know we have one example where we see a rose and how the petals grow naturally, and we also see them like in pine cones and seashells. So that's what we'll be showing the students today. So we have the wooden panels. We'll have them start with a sketch, and we'll try to sketch out the spiral, and then we'll add a painting on top of it to create that balance within the artwork.
All right, so are we ready to get these kids started?
Yes.
All right.
Alrighty, so all of you guys have your sheets where it shows you what the spiral looks like. So what I want you guys to do is to grab your rulers, because everyone have a ruler, and your pencils. And the spiral doesn't have to start right in the center. You guys could decide if you want it upper in your canvas, lower. Artists use it in different places, so it would be up to you where you want to place it. So wherever you want to start the spiral, put a little dot. So if I want to put mine a little bit higher up, then I'm going to put a little dot, and that's going to be your starting point. So you're going to put a little dot where you're going to start your spiral. And it could be in the center, it could be at the bottom. Got it? Alrighty. And with our rulers, what I want you guys to do, since we're going to start with 1, I want you guys to sketch it out so where you guys see your inches. So make sure it's the 0 and then inches, and the other side are centimeters. So make sure you guys are doing inches. We're gonna measure a square that is 1 inch by 1 and all around.
So one inch.
Yeah, by 1.
Okay, so
So it's gonna be
start
a
at
square.
the
So
dot.
all 4 sides are the
And then go
same.
Yep. And then I do, and then, yeah, either way. Mhm.
And it doesn't have to be perfect. When it comes to art, anything that's a little bit more organic, it's not gonna be super straight, and that's just because we're human beings, right? And this is fine in nature, so it's totally okay if it's not super perfect and precise. We always encourage a little bit of a little natural touch of our human. And then, so if we add 1 plus 1 equals
5.
1 1 plus 1,
2.
2. So we're gonna use the same square, and then we're gonna measure right next to it a 2 by 2 inch square. So it's gonna be attached, and then we're gonna go. Can you see that? It's gonna be attached, and then we're gonna go up.
You can go this way.
And it's okay if it doesn't end up fitting. It's just so we have a structure, a starting point. So it's like a,
Go all the way to the up. Yeah, there you go. Perfect.
so you guys are at this table, you guys are doing a square that's 2 by 2, right next to it.
Okay, so we'll let these kids build up their ratio, and then they'll start drawing their project, and then we will check back in with us in a little bit, and we'll see what's going on. Back to you, Mike.
All right, thank you, Sam. Also, thank you to Maria and the Bakersfield Museum of Art for helping us out with that one. The kids doing a lot of math right now before they get to the artistic part of that. In studio, we have 5th grader Jed from Del Rio Elementary. And head on over to the board, young man. We've got a problem for you. Since you said you were working on mixed numbers and adding and subtracting, we've got one for you right now.
Okay, so tell me what we're going to do here.
So first,
Yep.
you would find, oh, whoops.
Yeah, don't put your, there we go, okay. Try it again. All right, what are we trying to do?
First, we would find the least common denominator.
Okay,
So there's 8,
mm-hmm,
then there's 16,
mm-hmm,
24,
okay,
32.
okay. Do we need to keep going on?
Not yet.
No,
If we need to, we can.
okay,
So multiples of 3,
good,
3, 6, 9, 12,
okay.
15,
Still haven't found anything in common, you got to keep going.
18, 21, and 24.
All right, so first one we found that is the same, so good, so 24. So what does that do for us?
That gives us our denominator.
Fabulous, okay, good. So let's go ahead and change those fractions.
10 and 10 over 24.
Okay,
And 8 times 3 is 24.
Good.
So 5 times 3 is 15.
good, because we need to go ahead and change that numerator as well to make it equivalent. Good.
So 4, 1, 2, 3, 4, 5, 6, 7, 8.
Okay.
So 3 times 8
Right.
is 24.
Good.
So 3 times 2 is 6.
Oh, wait, what did we multiply by? We multiplied 3
Oh,
times
whoops,
8.
eight.
Good, so
That would be 16.
excellent.
So while you guys have the common denominator, you've gotten that far right now, I'm gonna let you guys keep working on it. But as you guys are, well, you wanna finish that up right now? All right,
Yeah.
go ahead.
Okay.
So 10 and 15 24s minus,
I'm going to give you some more room. Shall I give you some more room?
yeah,
Okay, let's go ahead and we'll do that. How's that?
4 and 16 24s.
Okay. And we are subtracting them, so let's not forget that. Good. All right. So
Oh, you can't take 16 away from 15.
good.
So you would subtract 1 from the 10.
Okay, so we are going to take part of that 10 apart, and we're going to do 9
9
and plus.
Plus
Okay,
24 over 24, which would equal 10.
right. So
And
there's that
then-
1 that we took away from that.
And then you
all right.
also add the 16. No, wait, the 15.
Good. And we might be out of. You want to come over here? So we've got.
Using every inch of that board.
Okay, so now let's rewrite it. Let's rewrite it over here. So the 9 and what's our fraction going to be now?
That would be 9 and 39
Good.
24s.
Excellent. Okay, so we still have 24ths, was exactly what we need.
And then 4 and 16 24s.
And what operation are we doing to those?
Subtraction.
Excellent. So let's make sure we don't lose our subtraction sign. And finish her out. Oh, I'm trying to give you more space and that's not working. There you go.
16 minus 39.
Backwards 39 minus 16.
Whoops.
You got it. We're good.
So that would be 23.
Excellent.
23 24s.
Uh-huh.
And then 4 minus 9 is 5.
9 minus 4.
Oh, whoops. Can't say
You're good. You're good.
So-
Okay. Now, is there any simplification we can do here? Because that's really what we should do, right? We should simplify it if we
Right.
can. Can we?
No,
No, we're done.
How do you know you can't?
because 23 and 24 don't have a common,
Factor.
common
Factor,
factor.
There you go, nicely done. Well, for some great work so far today, you got yourself a meal courtesy of our friends at Broken Hill Cafe, so congratulations on that. Hopefully you have an opportunity to head there soon and have a breakfast or a lunch. And right now, we're gonna see what X is all about.
Hi, I'm Ryan, and today I will be solving for x. This is going to be my problem. Pretty simple. What you want to do is get this x by itself, correct? So you want to get rid of 3. How do you get rid of 3? You have to do the opposite of the problem. So what is the opposite of positive 3? It's negative 3. So you write minus 3, and you have to do the same thing that you do on this side over on here. So minus 3, x comes down, and the equal sign, because this cancels out. So 9 minus 3 equals 6. X equals 6. Now, I'm going to be doing a harder problem now. So let's say 2x minus 6 equals 4x plus 2. See? Okay, so the first thing you want to do is get x on one side and the whole numbers on another side, correct? So you have to subtract the lower number first. So this is minus 2x on each side, minus 2x. So that this cancels out. The 2x comes down because 4 minus 2 equals 2. That's 2x. And now you have to get rid of the lower number. But now, see, we got rid of this one. So we have to get rid of this one. So minus 2 minus 2. 6 minus 2, negative 6 minus 2 is negative 8. Negative 8, you bring down the equal sign. So you always divide it by this one number because you always want to get this x by itself. So you divide this by 2, negative 8 divided by 2 is negative 4. So x equals negative 4. Now let's do another example. Let's say 3x plus 6 equals 9x minus 3. All right. So you want to do the same thing that we did that time. You want to get one side x, one side the whole number. So I want to get rid of this 3x because that's lower than this 9x. So minus 3x, gone again. And you subtract minus 3x, you bring down the result, which is 6x, equals. And so now that you've gotten rid of this one, you have to get rid of this one. And this one is the lower number, so you just add 3, 6 plus 3 is 9. Now here's something that you can do also. Whenever it comes to this, when it can't go in equally, you always bring down the 6, and x is going to equal 9 over 6. And these are some examples on algebra.
A lot of students always trying to find x. Have you had to find x yet?
No.
No? All right, well, hopefully, you know what, maybe we'll have you do a little bit of that later on
why?
today. Why? He needs to find it.
But
Not why, x.
sorry.
She's a funny girl today, huh? All right. We want to check in with the kids downstairs and see how they're doing with the art? Sure. All right, let's take a look downstairs and see what they're doing. So there they are. They, it looks as though he is
It'd be like you imagine, like,
maybe done with his measurement for the time being and trying to figure out what they're going to be doing next. So they are constructing their spiral right now. And there's Maria and Sam helping them out right there. And it looks as though his went off the canvas a little bit right there, but that's all right because these aren't always going to be perfect as far as being centered. So we'll let those guys keep working on that, and we'll check in with them in just a few minutes. But in the meantime, it's time to get you back to work. You ready?
Yep.
All right, back over to the board. So here's another one of the pages that you brought in, and so we're done with the mixed numbers. You feel good with those? Mm-hmm. All right, good. So here's another one of the pages you brought in. So 1/5 divided by 7. So go ahead and put that up on the board. 1/5 divided by 7. And explain to Cece what you need to do with that, and if you need some help, that's what Cece's there for.
So it's a keep, change, flip.
Okay.
You keep the first fraction,
All right.
1/5. You change the division sign into a multiplication,
Okay.
and then you flip the last fraction.
How do you just like flip it upside down?
So this is actually 7 over 1.
Oh, I get it. Okay.
So that would then be a 1,
Okay.
and that would then be a 7.
Okay, so we're taking the reciprocal. Very
Yeah.
good. Okay.
So then you multiply it.
Mm-hmm.
That would be 1/35.
Nice. Do you know why you do the whole change, flip, keep, flip, whatever you just said? Keep, change, flip. I got
Yeah.
it. I got it. Yeah, I got it. Why? Hard question, right?
No.
Okay. If I have, what does division even mean?
Division is how many times one number goes into another number.
Okay, so something like that. So if I start out with 1/5 of something, right? So if I have my rectangle 1, 2, 3, 4, I got 1/5 of it, yeah?
Mm-hmm.
Okay, I need to break it now into 7 pieces. So if I break all this into 7 pieces, is that right? Like we're trying to figure out how many we would have left, right? So we're just going to get down to just having the 1/35, right? Okay, so that's why we should always get something smaller if we're dividing by a whole number. What do you got for us? You want us to do another one?
Yeah, there's another one right here that we've got 9
Fantastic.
tenths. So 9 over
All right.
10
9
divided by
Tenths.
3.
divided by 3. So it's another keep, change, flip.
Okay.
So keep the
Yep.
first fraction,
Nice.
change the division into multiplication,
Okay.
and then that would be 1/3,
Okay.
which that would equal 9 30th.
Okay. Now, I don't like that answer, 9/30. Do you like that answer? Is that done? Are we done with that answer?
No.
No. Is it just because I said so, or because you're like, yeah, I know why?
Well, now that you said so.
Now that I said so, well, tell me. Because you said on that other problem, when I said, can you simplify? You said no, because there's nothing that divides into, right? We couldn't find a
Right.
factor that divided into. Is there a
Oh,
factor?
3.
Ah, nicely
So-
done.
And that 3 goes into 9,
Okay,
3 times.
nice.
3 goes into 30,
Uh-huh.
10 times.
Fabulous. And so that's our final?
Mhm.
Okay, I like that. That's
So
our
Cece,
final.
have them go back to where you were multiplying at the bottom and show them how to simplify at that point.
Okay, all right. So do you know how to do that?
I have it in the back of my brain.
It's in the back. Let's bring it to the front. Okay, so we know that we're going to end up simplifying by 3s, right? Okay, where else do you see we could simplify by 3s?
Right
Yeah, do you remember now?
Yeah.
What we're going to do? Okay, go
Sure.
for it.
So 3 goes into 9,
Okay,
3 times.
okay.
And then 10 goes into 1. Can't go into.
Okay, so what we're really saying is we're saying, okay, we're looking at the numerator and the denominator, right? Because when we multiply the top like this, right? Okay, so we're multiplying. Now, multiplication is commutative. Do you know what that means, commutative? Have you heard that word before?
I've heard it before.
It means, ooh, whoop, that's not it.
What just happened?
It means that we can switch places. Look at me in technology. That's amazing. Okay, so it's commutative because 10 times 3 is,
30.
what's 3 times 10?
3 times 10 is 30.
Good, okay, so we know that it's the same thing backwards and forwards. So we can do this, all right? Now look at this. 9 divided by 3, right? We would say, okay, 9 goes in 3 times, and we would reduce, or excuse me, I would simplify this to 3 over 1, yes? Okay. What's 3 times 1?
3 times 1 is 3.
Good. Put it up there. 1 times 10 is?
10.
Perfect. And that's how I can do it. So if it's multiplication, when we look at multiplication, we can look at their tops and our bottoms, and we can say, is there anything that we can simplify in our tops and our bottoms? And we can do that first, and then multiply across.
All right, nicely done. So I've got another one for you, but we're going to wait until we come back.
Welcome to Cal Poly, a distinctive, world-renowned university located in San Luis Obispo, California, and founded on one principle: learn by doing. For more than a century, we have proven that the most effective way for students like me to learn and grow is to jump right in, head first, and hands-on. And while we're known nationally for our engineering, agriculture, and architecture programs, Learn by Doing experiences mean that our students excel in every discipline and every one of our 6 colleges. Mustangs are uniquely positioned with the skills to shape the future of California, and when you help shape California, you change the world. It's one of the reasons we've been named Best in the West for 30 years and most innovative school in the West among public master's universities. It's why this year, we're able to recruit our most academically accomplished, most diverse incoming class ever. From our first days on campus, every student engages in an all-encompassing learn by doing culture that you just can't find anywhere else. From co-authoring peer-reviewed, faculty-led research to pursuing passion projects that connect their areas of study to real-world needs. Selena's son chose Cal Poly not just for the computer science program, but for the chance to build something new. Selena founded Slow Hacks to challenge students of all skill levels to use hardware, software, and code to build creative products in one weekend.
I think that hackathons are pretty much an essence of learn by doing. At a hackathon, you spend 12 to 36 hours building a project, which is pretty much what learn by doing is.
Thanks to Selena's leadership, Slow Hacks connects hundreds of students each year and serves as a recruiting event for tech employers.
As for Slow Hacks, I really hope that it remains as a prominent hackathon organization within California and that it's able to positively affect a lot of students around California and around the world.
Real projects with real consequences and real risk of failure. Any Mustang will tell you that is when you earn experience you'll never forget. Zoe Fox was among a team of architecture students who worked with residents of Paradise, California in the wake of the Camp Fire to envision a more resilient community.
This project is learning through service. It's kind of like an emotional investment in your work.
Mustang spent months immersed in resilient design with Professor Stacy White.
Working with a real client is a completely different experience than anything you get from really any other studio. You have to get into the details, like how can this be a real building that can be built and service real people.
On the final trip to Paradise, the teams presented their designs to a community determined to rebuild.
In reflection, I think we're all insanely proud. We've all developed this attachment to the people, to the community, to the project, and finishing is giving them this gift of design, which is the only thing that we can possibly do as architecture students to help this community that's gone through devastation.
Years of learn by doing means that graduates are ready day one to take their future into their own hands, ready to shape their careers, their communities, and California for the better. For NASA astronaut Victor Glover, he took his learn by doing attitude to the International Space Station. While in orbit, he relayed a special message to his fellow graduates.
I want to encourage you to continue to learn by doing. That doesn't stop after you graduate. It sure hasn't for me.
Glover is the latest in a legacy of Cal Poly astronauts. He piloted the SpaceX Crew Dragon and completed 3 spacewalks during his historic mission. Next, Victor could be headed to the moon through NASA's Artemis program.
I want to encourage you to dream big and to be patient and enjoy the journey.
You're now a graduate and member of the Cal Poly Mustang family. Congratulations!
So long for now. Keep shining. Graduates, from up here, your futures look very bright. I expect to see big things from this graduating class. Ride high, Mustangs.
He is one of thousands of Mustangs answering the call, going where California needs them, living a life of learn by doing.
All right, in studio, we've got Jed, a 5th grader from Del Rio Elementary, and has been working on some great math so far this afternoon. But right now, we're going to head back downstairs with Sam and Maria and check in with the Museum of Art and see how they're doing with their golden ratio.
All right, so the kids have gotten their golden ratio all sketched out, and they're starting with their ideas. So let's take a look at some of these ideas that the kids are working on. All right, so what have you decided to do?
I decided to make an eye right here, and then the eyebrows right there, and then that's kind of like the guideline of the head. And then I made more of it there, and then.
Nice, so you have your focal point here, and your spiral started going out. I love it. All right, what about right here?
I'm making a cat eye.
Okay. And you have your center,
eyebrow.
your focal point starts where?
And it's pupil.
Nice. So you have it here, right? This is your center? Nice, I like that. Okay. All right, and over here?
I'm doing a sunflower.
A sunflower, I love it. Yep. So she has her little center part started here, works its way around. The flower petals are slowly getting larger as she gets. Okay. Maria's got the other kids over here. We'll let her check in with them.
So this is my piece. I started doing a snail. So it creates that seashell spiral that also mimics the golden ratio. And we also have the kids doing a few of their own. So what are you making on your piece?
I am making a watermelon, and then I'm going to do a glass of juice or water up here.
So your golden ratio starts
here.
There. So anything starts really small and then it's spreading out.
Getting bigger, yeah.
Yeah, nice. Can't wait to see when you add color. Yeah. All right, and then we have right next. What are you
I'm making the golden snitch from Harry Potter.
Nice. So where the ball is, that was your focal point?
The circle goes here,
The spire.
The outside is being followed by the wings.
I love that. So you have one more wing to go. Nice. I love all the detail. And then we have one more student over here.
I'm doing like a Harry Potter theme with a Deathly Hollow, and then the snake is the symbol of Salazar Slytherin. Then, like, if you can sort of see it, it's like a Harry Potter scarf.
A scarf?
Scar.
Scar.
Yeah, the lightning bolt.
I love that. Yeah, so when it comes to this golden ratio, it doesn't have to fit the canvas perfectly. I know for some of the students it started going off the wooden board, and that's totally okay as long as it's the base at the bottom. It helps create a really balanced piece. So when people look at their piece, it's going to have a focal point, and then they could have some open space to create that balance of what's important and then what's in the background.
Okay. So now it's time for them to get some paint out.
Yes, so we're going to take out the paint and they can start adding some color to their amazing sketches.
Okay.
And we have the primary colors, so remember that we could mix colors together. So if we mix red and blue, we can make purple. If we mix blue and yellow, we can make green. And then we also have white if you want to mix and make more pastel and softer colors. So we'll make sure everyone gets every color. And then if you're ready, do place your wooden board on the easel so it doesn't get a little, too messy on the table. Yes.
And then if you guys want to make browns, just remember to mix your complementary colors.
Yes.
So we'll add a little bit of some yellows, and we'll get all the colors on here.
So always start with your focal point, so that's with the smallest part of your spiral, because that's where you want to put the most detail. And then as it opens up, then you guys don't have to, I need to mix this. We'll shake it.
Yeah. How big the snitches?
And we're using acrylic paint, so if you have long sleeves, try to pull them up. It is a little bit harder to take off clothes, but it looks really bright on wooden boards and canvases. And you guys have 3 different brushes. You guys have a white brush, a medium, and then a tiny one for details. So you guys don't have to use every single one, but you guys could decide which one works best for your piece.
And then should they get their brush wet first?
Oh, yes. So you guys have water, little containers of water. If you guys are using the same brush but different color, make sure you guys clean it before using a different color. And then you guys are going to be getting paper towels so you guys could clean your brushes. And if you guys have big areas where you want to add one solid color, then use the wider brush. And that's going to really speed up the process when you guys have a lot of open space with the same color. And you guys could always do a white base and then go over it with a color, and that's going to make the color look even brighter. How many of you guys have used acrylic paint?
We'll pause here for now. We'll let these guys paint, and we'll see you guys back here in a little bit. Back to you, Mike.
See what they do once they add that color on there with all the great ideas they've had so far. It looks pretty cool, huh? All right, you know what looks even better? You doing math on the board. So head on back over there. All right, so you and Cece were working on fractions like 1/3 divided by 9, okay? What I'd like you to do is write up there 10 divided by 1/2. Now I want you to just think, what do you think that might be?
The same thing. It's
What do you think the answer
change,
will
flip. I think it would be.
What's 10 divided by
double
1/2?
Right. 10 divided by 1/2 is 5.
So you think it's 5?
No. I think it's the keep, change, flip.
But you think it'll end up at 5?
No.
No? What do you think it might end up as?
I really don't know.
All right, well, go ahead and go through it.
Do we want to think about it a little bit?
Well, I was going to say, think of it because a lot of kids look at that and go 10 divided by 1/2 is 5.
Right.
which is what came out of his mouth. So
Right,
like, all right,
right,
5,
right.
but
Okay, so
think
again,
about it a little
we
bit.
need to think about what it means to divide, right? So we're breaking it into halves. How many halves are we going to have if we start with 10?
2.
If every single one is broken into a half, how many halves go into one? How many halves make one whole?
2.
2. Okay, so if we have 2 halves for every whole, then how many, if we have 10 wholes, how many halves are we going to have?
Pretty sure that would be 5.
Okay, let's try it. Let's do our change, keep, flip. Or flip, keep, flip, change. I got this.
Keep, change, flip.
Keep,
Eventually,
change.
it'll
Words.
get
That's
there. Who knows?
words.
I always think of the KFC and then rearrange them a little bit. Yeah, see, because working that way is not going to do it, right? You have to reason your way through it, and that's just one of those things where a lot of kids memorize keep, change, flip, but aren't sure why
it
they're
is.
doing
Yeah,
that.
yeah,
That's
yeah.
why we're going through this process.
So we're saying, so if I have 10 wholes and I'm dividing it into halves, I have a half and a half gives me 1. A half and a half gives me 2 more. Half and a half, right? That's how we get to 20, right? Very good, okay.
Right, and I wanted you to go through that because the numbers were reversed before, the fraction first, and a lot of kids, they see 10 and a half and they automatically go 5.
Yeah.
Right, just like 20 divided by half,
Right.
10.
Right.
Same thing.
So if we're taking a whole and or if we're taking anything and dividing it by this fractional amount, we're generally going to get something bigger, right? Because we're breaking it into
You
fractions.
guys ready for something completely
Yes.
different?
Please.
All right, so let me, I'm going to go back a few pages here.
Okay.
And I'm going to show you a little something that I had prepared for you. A lovely little surprise. Here we go. I can see the smile on your faces, just like the little smiley faces in the middle of all of those right there. So we have section 1, which is on the upper left. And up there are 9 boxes. Okay, there's a 1, 8, 1, 8, U in the middle, and an 8, and 1, 8, 1 on the bottom. Okay, so there are altogether, what is your favorite animal?
Elephant.
Elephants. All right. So you have a number of elephants, and you don't want to lose any elephants. You're in the middle of this big elephant pen. And every time you look and you turn one direction, you must see 10 elephants. Okay? So if you're right here and you looking up, you see 10 elephants, correct? You see a 1, 8, and 1? Does that make sense?
Yeah.
Okay. So if you turn to your left, you are now going to see 10 elephants, correct? If you look down, you're going to see 10 elephants. And if you look to your right on the other side, you're also going to see 10 elephants. Okay? But I come and I take some elephants from you.
That's so mean.
But I rearrange the elephants so that you, now it's section 2 down here, if you look up, there are still 10 elephants, aren't there? And if you look to the left, there are still 10. Down, there's still 10. And to the right, there's still 10. You have no idea what's going on. You're like, I still have 10 elephants everywhere I look. I go, all right, I'm going to go take some more elephants. And you won't even know. So up here in section 3, you still see 10 elephants, don't you? Even though I rearranged them, you still see 10. And you still see 10 everywhere you look. And I've done it to you now 3 times. And I'm going to go, you know what? Let me take some more elephants, because I love elephants myself, all right? So I take more elephants. And now you are going to look, and you still see 10 elephants all the way around. All right? Can you and Cece talk about why are there still 10 elephants all the way around, but I'm still taking elephants? Because if we look up here, right, how many elephants are there altogether? Count the 8s. 8, 16, 24, 32, 33, 34, 35, 36. There's 36 elephants up there, right?
36 right there for just a minute, just so that we remember that there was 36 total. Okay, I like
Now
that.
let's jump all the way down to the bottom, down here. Okay? Let's count the 5s. I have 5, 10, right? You want to do the 2s or 3s next?
Let's do 3s.
The 3. So 10 and 3 is 13, and 3 is 16. 18, 20, 22, 24. So you ended up with 24. So go ahead and put a 24 down there. So you started off with 36 elephants. I took 12 of them. And you don't even know that they're missing because you still see 10 everywhere you look. See if you and Cece can kind of take a look and see why did that happen? Why was I able to take 12 elephants from you, yet you still see 10 everywhere you look?
What are you thinking?
I'm really confused.
So let's. I'm gonna go back just really quickly. I kind of want to know how many are in here. So 6. We got 4 6s. That's 24, right? And then that's 8 more. So 24 plus 8 is
32.
32. Okay, so this is 32. So let's go ahead and we're gonna say that's 32. Okay. How about this one? So we've got 4 4 4. 16 plus.
19, 22, 25, 28.
Okay, so I'll go ahead and put a 28 there. So look at what's happening each time. This was just sort of like what I was thinking in my head just really quickly. We're losing 4 each time, right?
Yeah.
So it looks to me, what's the other thing we maybe notice about this? That we go from 1s and 8s to 2s to 6s, and then what are we doing here?
3s and 4s.
3s and 4s. Okay, so forget that one. That looks super weird. I like this for right here to kind of give us this little pattern, right? So what are you noticing on these patterns?
I'm noticing that everywhere you look, there's 10 elephants.
There's 10 elephants. Okay, tell me about, but look, we've got 1, 2, 3, but those are my corners, right? And then here we're getting 8, 6, 4. Right? So we notice that he's reducing here, right? He's reducing on those by what each time?
By 2.
Okay, so what's happening then? So if he's only reducing this by 2, that would be 8 total that he's taking out, right? So he would be taking 8 total elephants out if all I was reducing here, but we only reduced by 4. So what happened with the rest of what happened with my other elephants?
They stayed.
They stayed. And where did they go?
They stayed in the pattern.
They went to my corners, right? So he took out 2 out of each of here, right, going from 8 to 6. But he didn't take all 8 of them away with him in his trailer. He just took 4 of them, and he went ahead and took the other 4, and he said, well, I've got 4 corners, right? So same thing here. We're taking out 2 out of each of these, and then just taking 4 away, and then distributing back to the corners.
Right, so I'm going to let you guys keep thinking about that for a little bit because you're on the right track. So keep on working on that. Right now, because I know those guys have started painting a little bit, let's check in downstairs.
All right, so let's check in with some of these kids. They've started painting and we're getting a lot of mixing of colors. So let's see, what have you got going so far?
So I finished almost the eye, and then I'm trying to get like a brown color. So far I've used the black, the yellow, the dark green, and the red, and it made like dark brown, which I'm going to use for the eyebrow.
Great.
And
What colors did you use right here to blend for that one?
then, so I used like the blue with some of the white, and actually I used the kind of the white, the dark green, and a little bit of blue and a little bit of red to get like
I love it. It looks like a hazel color. All right, good job. Okay, I can't see you. What have you got for yours so far?
Right now I'm coloring the eye and I'm just doing the little details.
Oh yeah, good. And you've made yourself a little kind of a pastel turquoise. Looks very nice. What are your next colors are you thinking?
I'm thinking of making the cat brown and maybe the nose pink.
Oh, that would be cute. And this is the little nose right here? Very nice. Okay. And let's check in with yours. Oh, I love it. That looks so good. And you worked hard on mixing your browns. What did you use?
I used all of the colors to mix the brown for the seeds and like the inner part of the sunflower.
Yeah, that looks great. And what color are you going to work for your your petals?
I'm gonna use I'm gonna make orange and make it a lighter orange and then use yellow.
Great, that looks awesome. All right, let's check with this table over here. All right. Yeah.
So we have a watermelon, and you've been mixing some colors. What have you been doing with your paint?
So with the pink, I did a tiny bit of red and a lot of white to make that pink, which is the pink lemonade up here. And then I'm doing white ice cubes with a little bit of gray as a shade. And
To make it look 3D?
Yeah. And that's all I've really planned so far.
So you have your lemonade in the background, and then your watermelon's gonna be in the foreground to make it stand out.
Mm-hmm.
And you're gonna be making it red with the black
red,
seeds?
and so I'm gonna do a little bit lighter up here with some white, so it looks like the light's hitting it, and then darker red around the edges.
So it's helping you create that illusion of distance.
Yeah.
Something that's very far,
Mhm.
something that's really close. Great job.
That looks awesome. What about you? You've got lots of mixing going on here?
I've been trying to create a good golden color for some of like the
That
outlines
looks
and
great.
highlights. I think I got a pretty good one. I'm just gathering it up now, getting ready to put it on my paint.
That looks awesome. What colors you add in there?
I put yellow, red, and a tiny bit of green.
Yeah, great job. Okay, and what about down there?
You're mixing some colors?
Yeah, I'm trying to get a brown color for the wand that's right there. And I used black for the outline right there. I made a tiny golden snitch, a snake, sock, some other things. Yeah.
So you have a lot of detail
Yeah,
for
you do.
your canvas, so you're going to be making a lot of mixing.
What colors have you used so far?
Blue, red, and black.
Okay.
I
And
know
so
it's sort of gray, but
yeah, and these two will make a purple, right? So if you pick a color that does not blend with those, like the complement to it, so if that makes purple, if you add the complementary color to purple as yellow, it'll make a brown. So if you added a tad bit of yellow in there, you'll probably get a lighter brown. Very cool. So Maria, tell us about the museum. So what programs do you guys offer for kids?
So right now we are getting ready to get our registrations open for the spring workshops. So during spring break, we offer classes at the museum. So if you have little ones that are in pre-K and K, we'll have a couple classes offer for them. Kids from 6 to 11 will be in the morning, and then teens from 12 through 17 will have some classes in the evening, afternoon.
Great. And is that every day over spring break?
Every day for spring break, and then we'll be having our After Dark next week for more of the adults.
Great. All right, well, these kids are going to keep painting, so to see some finished products, let's check out our social media. All right, back to you, Mike.
Maria, thank you, Sam. And in studio with us, we have Jed, who's working on this final problem. So what did you guys find out?
We found out that it's actually sharing the corner number.
Okay.
So it's kind of using like a little bit of that number.
So I'm just rearranging the numbers so that you constantly see 10, even though I'm taking some away. All right. So did you learn a little something today? Good. Did you have fun today?
Yeah.
There you go, right there. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.